This isn't even on your sheet yet, but what I want to do is I just want to know. So chain rule is for composition of functions. You guys remember doing these, especially algebra 2, f of g of x. Sometimes written like this. Or that was there two functions in one, or more. It could be three functions in one. So we haven't seen any of those yet because we would not do it. All right. So the chain rule is how we will do these. So the question is how you do the derivative of this. All right. So what's the derivative of a composition? So first I want to just do this real quick. I want to write down a function, and I want you to thumbs up if you think if there is a composition, and thumbs down if you think there is not a composition, meaning more than one function. Okay. So I'm going to write down a function. I want you to tell me if there's two functions in one, f of g, or if it's just one function. Okay. So let's just start. X squared plus 3x. Just right in front of you. Thumbs up or thumbs down. There is a composition or there's not. If you're not sure, just take a guess. Thumbs. And okay, pretty good. The answer is no. There is not a composition. There is not two functions. There's a sum rule we would use. There's separate functions, but there's not functions combined that are together. Let's try another one. That's a 4. 4x minus 2 to the fifth. Again, is there more than one function, a composition of functions? Yes, thumbs up, no, thumbs down. In the back. I don't know what that is. Kind of, yes. Okay, that's pretty good. Yes. Yes, there is. The two functions are 4x minus 2, and then you could call it y to the fifth, or I'm going to be calling it u to the fifth, something to the fifth power. There's two things in one. Normally it would be like, I want to use a different variable. It's like kind of like something to the fifth power, and then 4x minus 2. So there's very, very different, these two. Okay, so what about square root of x?
I have a question.
Okay, sure.
So if the 5 wasn't there, then it would be a no?
If it was just 4x minus 2, like,
Right.
but to any other power, it would be, yes, there is.
Yeah,
Yeah.
okay.
But yeah, just 4x minus 2, that's a good question, thank you. Yeah, it would be no, there's not a composition. Trying to help you identify, because this is usually the hardest part students have. When do I need to use chain rule? Okay, that's the question. If there's a composition, then the answer is yes, you need to use chain rule. So square root of x?
No.
Thumbs up or thumbs down? Is there a composition? No, there's not. How about this one? Square root of 3x minus 1. Thumbs up, thumbs down. Here, is there two functions in one there, or is there just one function? In the back? Yeah. Yeah, the two functions. There is 3x minus 1 is a function, and then square root, I'm going to start calling it u. Square root of something. Square root of x is your function, 3x minus 1. I'm trying to show you the difference in these. Here, let me show you one more. Sine x. No, it's just, and we know the derivative, it's cosine. Sine of 2x, even just 2x, I've been writing like 2x plus 1 or something. Even just something as simple as putting a 2 in front. That's now two functions in one. 2x is one function, and sine of x, or sine of u. Or it could be something like sine of x squared. So my point is, if you have a parent function, right, just sine of x, there's no transformations if you think back to that. Do I need chain rule? No. As soon as this changes to anything but x, 2x, 3x minus 1, then there is a composition of more than one function. You would need chain rule. Okay, so let's see. Any thoughts or any other questions on that right now? I probably should have put some on there for you, but as we go through, we'll see a lot of these. So the idea is, if there's a composition, chain rule. If there's not composition, then no, you'll just do power, product rule, things we've normally done. So let's look at this more explicitly here. So I'm going to give you an example. 3x squared plus 1 squared, find the derivative. I want to show you two ways to do this one. Moving forward, if I would change this to like 12, or some other, we wouldn't do option A. So there'd only really be one way to do this. So right now, before chain rule, the only way we would know how to do this is to FOIL. So I'd have to write it as 3x squared plus 1, 3x squared plus 1. I'm going to FOIL and do the derivative. And then what I'm going to do is show you how to do a chain rule. And we'll do the same thing.
So you have to write this down.
Yeah. I want you to see how it changes. So I'm going to FOIL. F, my first is 9x to the 4th. Outside is 3x squared. Inside is also 3x squared. And last is 1. So I get 9x to the 4th plus 6x squared plus 1. So that is just y, my original function. I'll do the power rule. 36x cubed plus 12x. Again, I can only do this because it's just to the second power. But what the chain rule is going to be good for it is, well, what if it was to the 10th power or something else? We can easily do it instead of writing it out 10 times. So I want to show you this. Now what we're going to do, I'm going to do the chain rule basically in part B and show you that I'm going to get the same thing. Okay, I'll show you that I'm going to get the same thing. Oh, and by the way, the composition is, there is a composition, right? 3x squared plus 1 is one function. Something squared, x squared, or I'm going to write starting u squared is my other function. Okay, so let's do the chain rule. Here's what this would say. So in chain rule, I'm going to let u be the inside. Okay, what I boxed right there. Would you guys agree that like there's two, like an outside and an inside, f of g of x? We used to do this. There was a function that was inside another function. That's what composition is. So in this case, my g of x, my inside function, which I'm going to start calling u, is 3x squared plus 1. You guys okay with that? No, that was the inside part. The outside function is what I was saying up here, something squared. I'm going to since I called u the inside. Now my outside function is something squared, it's u squared. Here's what the chain rule says. I'm going to do the derivative separately and combine them. And this will be the overall derivative. So what I'm going to do is I'm going to do the derivative. I think I'm just going to write u prime. Yeah, that's fine. There's another notation I wrote down here, but let's just I'll do u prime and y prime. So I'm doing u prime. I'm doing the derivative of u with respect to the x variable. This is why I almost want to write du dx. The derivative of u with respect to the x variable. So these are the same thing. U prime in this. 6x, right? 6x plus 0. I'm going to do the derivative of y. So this is dy du, the derivative of y with respect to u. All right, and it's 2u. Okay, and here's what the chain rule says. It says the overall derivative, which really was this one, right? Well, my function was y. Y equals something squared, 3x squared plus 1. My overall derivative is going to follow this one right here. So I'm going to get y prime. This is my overall derivative. It was 2. But then so it's multiplying the derivatives that I got. going to be 2u times the one I got here. Let me write this out over here. So the overall is going to be 2u times what I got over there, 6x. So I'm multiplying the two derivatives. The only other thing that I want, though, is I want the original function's variable, x. So right now I have u and x in there. So I know what u was. It's 3x squared plus 1. So I put that back in for u, and then I simplify. Let me distribute in the 2. So it's 6x squared plus 2. And then let me distribute in the 6x, and it's going to be 36x cubed plus 12x, which is what we got in the first one. Now this, part B, would be the only way we would do it in the future if the exponent was higher than 2. We wouldn't want to do it more times. So what this says is you do this one was the derivative of the outside function. This was the inside function. You do each derivative, outside and inside, but you put the inside one back in once you've done the derivative. I'm going to sum it up below, but the chain rule is what this will be called for the derivative of composition. So again, this is an intro example to show you that we get the same thing for each of these. So this is going to be the way that we do it in the future. So let me outline it for you in this table. Any thoughts on before we do? So again, this is for differentiable functions that are in the form f of g of x. Okay, you've written like, well, I like this one. Those are the same. So here's what it is. This is the part you should box. Here's the chain rule. The derivative of this is f prime. So this was the outside derivative, keeping the g, and then this was the inside derivative. So then times the inside. So I want to show you in ours. So the f prime, the derivative, that was the 2, well, it was just the derivative, that's 2, and then u. That was this. You kept the g, you keep the inside, that was this. So if you go back to the original, 3x squared plus 1, that's that. And then times the derivative of the inside, that was this. So if you're looking for a formula to go off of, it is this one. Derivative of the outside function, keep the inside. So this is the g, just keep the inside. Then the derivative of the inside. I wrote it up here in a different notation. This one's actually a little bit more clear. It just tells you what derivative in respect to what variable. But this is the general formula that you're going to want to remember. So let's do this example below, and then I'll see if there's any more questions. I made it similar to the last one, but I made it to the 60th power. So there's no way we would want to do this 60 times. Like, right, FOIL it out 60 times. So instead, we can use the chain rule, and it's pretty simple. So let's follow this. Oh, let's follow this above. As long as I can identify the inside and outside functions, then I'm going to be okay. Outlined in green, that's the inside function. There's a composition. That's the inside. Let's put in blue here. The outside function is that something to the 60th power. I'm just trying, it's really the 60th power. So it's really, this is where I use a different, I'm not going to say x to the 60th. We use a different variable. We normally call it u. The outside function is really u to the 60th, something to the 60th power. Okay, so then here's what you do. You identify how do you do the derivative of this. So what rule would I apply?
Oh,
To
power.
Power rule, right? It's something to the 60th power. It's variable to the 60th power. I do the power rule. So right here, I'm on this. I'm doing f prime. Or this is really my f. It's u. That's really my f. So I do the derivative of that. 60, then whatever's here, this is where, it's really 60 u to the 59th, right? I'm going to write that out. So I'm going to leave it blank there, though. So it's 60 something to the 59th. Normally you would write in u, but my u is the green. The u is the inside part. I don't want to say g, but g is really, that's the u, the inside part. So I do 60 u to the 59. Well, I don't write u. I write what the original inside was. You see how this hasn't changed, the g? Still g there. So the inside, my g, my u, is 2x squared minus 4x plus 1. That might seem kind of natural. I did the power rule. You kept the inside. Then I multiply. There's a times right here. It's hard to see here. There's a times. Times g prime. So whatever the inside function, also u prime. Okay. So I multiply whatever the inside derivative is, which is 4x minus 4. Okay, that's it. I guess I could combine the 60 and the 4x minus 4. I cannot multiply the 60 by this term to the 59th and the 4x minus 4 times that 59th. No, but I could do 60 and 4x minus 4, but I'm just going to leave it like that. You see how I outlined the colors? So this is very important. I did. Oh wow. Outside derivative, 60 something and 59. Leave the inside. That's the green. Outside, and then out here I put the inside derivative. And that's the process every time. Part 2, we'll do a couple more tomorrow. Good job. Any questions I can answer?